In 1989, a woman in London noticed something strange about her dog. The dog would not stop sniffing one particular mole on her leg. It was not a quick sniff and move on. The dog was obsessed. When she wore shorts, it even tried to bite the mole off. She went to her doctor. The mole was melanoma. It was caught early enough to save her life. That case was the first documented instance of a dog detecting cancer in a human being, but it was far from the last. Since then, researchers have discovered that dogs can detect at least a dozen medical conditions, from cancer to diabetes to Parkinson's disease. In some cases, they do it more accurately than the medical equipment sitting in your doctor's office. Here is why. It starts with how different your dog's nose actually is from yours. You have about 6 million scent receptors in your nose. Your dog, depending on the breed, has between 100 million and 300 million. That is not a small upgrade. That is like comparing a flashlight to a searchlight. A dog can detect a substance at a concentration of 1 part per trillion. To put that in terms you can picture, imagine 20 Olympic-sized swimming pools filled with water. Your dog could find a single drop of something dissolved in all of that water. Their nostrils are also built differently than ours. When a dog breathes in, the air splits into 2 separate pathways. One goes to the lungs for breathing, the other goes straight to a dense network of scent-analyzing tissue deep inside the nasal cavity. Dogs also have a specialized organ called the Jacobson's organ that processes chemical signals humans cannot even perceive. They are not just smelling better than we do, they are operating an entirely different sensory system. That system, it turns out, can read your body like a medical chart. The cancer research that started with that London mole in 1989 has expanded enormously. Scientists now know that cancer cells produce specific volatile organic compounds, chemical byproducts that get released into your breath, your blood, your urine, and your sweat. Healthy cells produce a different chemical signature. Your nose cannot tell the difference. A dog's nose can. In one study, researchers trained 4 beagles to distinguish between normal blood serum and samples from patients with malignant lung cancer. 3 of the 4 dogs identified the cancer samples with 96.7% accuracy. The 4th dog, a beagle named Snuggles, was reportedly unmotivated to participate, but the other 3 nailed it nearly every time. And it is not just lung cancer. Dogs have been trained to detect bladder cancer from urine, prostate cancer from urine, colorectal cancer from breath and stool samples, breast cancer from breath, ovarian cancer from blood and tumor samples, and melanoma from skin. In a more recent pilot study involving 10 different cancer types, dogs achieved a 96% overall detection rate. Some researchers believe there may be a common scent signature that runs across multiple types of cancer, because dogs trained on one type have sometimes detected others they were never exposed to in training. But cancer is just the beginning. What dogs can do with blood sugar is, in many ways, even more immediately life-saving. Diabetic alert dogs are trained to detect dangerous shifts in blood sugar levels by picking up on chemical changes in their owner's breath, sweat, and saliva. When blood sugar drops too low, a condition called hypoglycemia, the body releases certain compounds, including one called isoprene, that change the way a person smells. The change is invisible to everyone in the room except the dog. Some of these dogs alert their owners up to 30 minutes before a continuous glucose monitor picks up the same change. That is not a small margin. For someone with type 1 diabetes, a blood sugar crash can lead to seizures, loss of consciousness, or worse. Those 30 minutes can be the difference between grabbing a snack and ending up in an ambulance. One woman who has lived with type 1 diabetes for over 40 years said her dog has saved her life so many times she has stopped trying to count. The dog alerts her long before her monitor beeps, and if her blood sugar starts dropping while she is asleep, the dog jumps on her and licks her face until she wakes up. Now, seizures. This is where things get especially fascinating. Some dogs can sense that an epileptic seizure is coming before it happens, not during, before. The dog will suddenly change its behavior, become agitated, start pawing at its owner, or refuse to leave their side. Minutes later, the seizure hits. For a long time, nobody understood what the dogs were picking up on. Then, a research team in Germany ran a 7-year behavioral study with 14 dogs and 24 human participants, including epileptics, diabetics, asthmatics, and migraine sufferers. Every participant wore a pulse oximeter on their finger that measured oxygen saturation in their blood. Here is what they found. Before a diabetic's blood sugar crashed, their oxygen saturation dropped. Before an epileptic had a focal seizure, their oxygen saturation dropped. Before an asthmatic had an attack, their oxygen saturation dropped. Before the migraine sufferer had an episode, their oxygen saturation dropped. And every single time the oxygen level fell by 3 to 4 units, the dog stood up, walked to the person, and gave an alert. The dogs never alerted with any of the 12 healthy participants. Not once across the entire study. They were not reacting to behavior or facial cues. They were detecting a physiological change in the body that was imperceptible to everyone else in the room. Think about that for a second. A dog lying on the floor of a room can sense that someone's blood oxygen level just shifted by 3 units. The machines did not beep. The person felt completely fine, but the dog knew. If you are finding this helpful, hit subscribe. We cover the kind of things about dogs that you will not hear anywhere else, and there is a lot more coming. Parkinson's disease is another condition that dogs have proven they can detect, and this one carries a detail that is almost hard to believe. People with Parkinson's produce excess sebum, an oily substance secreted by glands in the skin. That sebum carries a distinct chemical signature. A woman in Scotland named Joy Milne, who has an unusually strong sense of smell, noticed a change in her husband's scent years before he was diagnosed. She described it as a musky, oily smell that was different from anything she had experienced before. Doctors initially dismissed her. Years later, after her husband's diagnosis, researchers tested her ability under controlled conditions, and she was accurate. That discovery led scientists to train dogs on skin swab samples from Parkinson's patients and healthy controls. In a double-blind trial, 2 dogs achieved sensitivity between 70 and 80% and specificity up to 98%. A larger study with 23 dogs of various breeds, from poodles to dachshunds, averaged 89% accuracy over 2 years of testing. These were not specialized lab dogs, they were household pets. The implications are significant because Parkinson's is currently diagnosed based on motor symptoms, which means by the time a doctor confirms it, the disease has already progressed considerably. A scent-based screening could catch it years earlier. Dogs have also proven effective at detecting infectious diseases. Trained dogs identified children infected with malaria parasites 70% of the time just by sniffing socks the children had worn overnight. During the global pandemic, dogs at Helsinki airport screened arriving passengers in real time by smelling their skin. French researchers found that dogs could detect the virus from armpit sweat samples. Across multiple studies, the dogs performed nearly as well as standard laboratory tests, and they delivered results in seconds rather than hours. What makes this especially promising is how fast the dogs can be deployed. Training a dog to detect a new disease takes weeks, not years. When a new health threat emerges, dogs can be on the front lines screening people at airports, stadiums, and border crossings long before new laboratory tests are developed and distributed. For diseases like malaria that devastate developing countries where lab equipment is scarce, a trained dog and a bag of worn socks could be a genuine screening tool. But here is what might matter to you the most if you are a dog owner. All of those studies involved trained detection dogs. Dogs that spent months or years learning to identify specific scent targets. What is harder to explain, and what researchers are still working to understand, is the untrained household dog that saves its owner's life without a single day of formal training. There are documented cases of pet dogs who became fixated on one specific area of their owner's body. Not a general interest in sniffing, but an obsession. The dog would sniff, lick, nip, and paw at the same spot every day, sometimes through clothing, sometimes waking the owner up at night to do it. One owner described her dog pressing its nose against the same area on her chest for weeks. She kept pushing the dog away, thinking it was just being annoying, but the dog kept coming back. Eventually, she mentioned it to a doctor on a whim. It was breast cancer in a spot she never would have checked on her own. Owners who followed up with doctors because of their dog's persistence have discovered melanoma lesions, breast tumours, and other cancers in the exact spot the dog had been targeting. Nobody trained these dogs to do this, and nobody rewarded them for alerting. They simply would not stop, and their owners were smart enough to eventually listen. Researchers are now racing to translate what dogs can do into technology that scales. The Massachusetts Institute of Technology and an organization called Medical Detection Dogs are working together to build artificial intelligence systems that learn from the way dogs process scent. The goal is to eventually create electronic noses that can screen blood, breath, or urine for the same volatile compounds that dogs detect, but without needing the dog. The problem is that dogs are still better at it than any machine humans have built. Their noses remain more sensitive, more flexible, and more accurate than the most advanced electronic sniffers in existence. The technology is catching up, but it is not there yet, which means, for now, the most sophisticated disease detection system on the planet might be lying on your couch right now, waiting for you to come home. So the next time your dog sniffs you a little longer than usual, or keeps pressing their nose into the same spot, pay attention. They might not be looking for crumbs. They might be trying to tell you something that could change your life. If this blew your mind, the video on screen goes even deeper into what your dog knows. You are going to want to see it.